Okay, so we want to set up an integral, spelled integral wrong, for volume under f of x and y is 2x squared plus 2y squared. Above g of x and y is minus 4 square root of x squared plus y squared, and inside of x squared plus y squared is smaller than 2. So, do you guys want to do this the I know what these things are way, or do you want to do it the kind of naive way, or what?
It's naive way, please.
Okay, so let's try the naive way. So the naive way is to say, all right, there's lots of x squareds plus y squareds kicking around, right? So what do I know about x squareds plus y squareds?
1.
There are squareds, right?
Oh, it's this.
Okay, so let me just make those substitutions. Then f really is the same thing as 2r squared, right? What's g?
Yeah.
It looks like negative 4 square root of r squared gives you negative 4r, right? And what's the inside of thing? Yeah, it's a circle, right? That's r squared is less than or equal to 2. Yeah? Okay, what is all this business with r's suggesting in terms of a coordinate system? Cylindrical, probably, right? Because I'm using x squared plus y squared. If there was plus z squared, I'd be thinking spherical. If there isn't, I'm thinking cylindrical. Okay, so I throw down my cylindrical stuff. And then, which thing's going to come first here?
0.
Okay, probably on the outside there's a 0 to 2 pi for the thetas.
And then you do z first, because your z's aren't specified.
Good, there's no z's in the problem, right? Well, except that they tell me there's above and below, right?
Yeah.
So where do your z's start? They start at the thing on the bottom, right? So they start at the below?
So negative
Or
4.
they start above G.
Yeah, so I'm supposed to be above G, right? So that's the thing on the bottom. So my R's should go from G, right, to F. So what's G and R's?
And z. You plug in
Oh,
r's.
sorry. I want to be integrating the z's out. Where do the z's go? They go from G to F,
Negative 4r equals 2r squared.
and G is negative 4R, and F is R squared, 2R squared. And now what's the other thing I need to get rid of here?
Our r's.
Our R's. And where do the R's range from?
0 to square root of 2.
Yeah, they start at 0, right? Because I'm inside of this circle, and they get to R squared is less than 2. That tells me they get to square root of 2. Perfect. Integral. Set up. Done. Done. Does that help?
Yeah.
So the kind of not naive way would be to look at this and think, okay, this thing's a paraboloid. This thing's a half a cone pointed downwards. And this thing's a cylinder. So I'm looking for above a cone, under a parabola, inside a cylinder. That's definitely suggesting cylindrical. And then my z's start here, stop there. Same conversions.
Okay, I drew wrong pictures. That's what I was saying, because then I was trying to do spherical.
Oh yeah, so
I had no idea what to do.
you could set this up in spherical, right? But it's going to be really, really nasty because this thing in spherical has a horrible expression. So well, one of your variables is gonna go from someplace nasty to someplace else nasty.
Yeah.
Yeah. This is this thing, right? Your cone. That's pretty convenient for the fees, but this thing's horrible. The parabola is horrible for fees,
And limiting it to a cylinder.
and limiting it in a cylinder is even worse. So yeah, spherical's just kind of gonna be a disaster, even more so than Cartesian here.